Hi, my name is Agnieszka Nyka. I'm a management accountant, Excel expert, and a founder of Purpose Logic. And my motto is everything is Excel automatable until proven otherwise. This is my very first video, and it's not your usual accounting or Excel tutorial. Far from it. It's actually a presentation about solving puzzles in Excel. Now, you might be thinking, what does this have to do with accounting? Well, I actually specialize in Excel-based automation for management accountants. So if a large part of your month-end reports is manual and your excuse for not automating it is my management accounts are very complex, like Rubik's Cube complex, well, guess what? I've got that covered. Yes, this is Excel, just formulas, no coding. Or maybe your excuse is trying to automate my management accounts would be like walking through a maze of formulas, tabs, links, maybe not even one maze, maybe several mazes at the same time. Well, I've got that one covered too. No excuses. I hear these all the time, and I'm here today to make you rethink what's possible in Excel. Because if I can rotate a cube or walk through a maze inside Excel, then you better believe that your management accounts can be automated too, no matter how complex they are. I know we've only just met, but if automating your month-end reports is on your mind, then I've put together a step-by-step walkthrough that shows you exactly how I do it and how you can do it too. There is a link below if you're curious. No pressure, just check it out whenever you're ready. Now, the puzzles you're about to see, they are not just for fun. They are proof of what Excel is capable of in the right hands. More about who I am and why I build this crazy stuff is all inside the presentation. Now sit back, enjoy, and maybe ask yourself, what if my management accounts could be automated just like these puzzles? Hi everyone, welcome to my presentation, Logic in Motion, Excel puzzles that make you think differently. These projects have certainly shaken how I think of Excel, and who knows, they may shift your paradigm too. Quick disclaimer, I'm not a professional presenter, so don't expect a technical perfection here. But I am professionally obsessed with and passionate about Excel, and I'm here to show you what it's really capable of. Now, let's be honest, most people, my past self included, think Excel is just for numbers, data tables, charts, until they see something like this. For example, a Rubik Cube animation in Excel. And that's the usual reaction to it. So the natural question then is, who on earth builds that in Excel? Well, it's me. My name is Agnieszka Nyka, and I have been obsessively passionate about Excel automation, Excel-based automation for over 20 years now, building smart Excel-based systems and solutions for myself and for fellow accountants. As I also hold a degree in mathematics, which is no doubt responsible for my obsession with spreadsheets and puzzles, things like systems, automation, logic are second nature to me. So I'm here today to talk about puzzles, a pointless play, no real purpose, maybe even waste of time, or is it? Because I've actually found that the more puzzles I solved in Excel, the better I got in tackling real world problems, which are actually also just puzzles, except they are less colorful. So the playing with puzzles has truly changed how I see financial models and workflows now. And that shift hasn't actually started with the puzzles, but more about it a bit later. So me and Excel, it was love at first click. I first encountered it as Excel version 97, the ancient version where you had to carve the formulas in stone, if you remember that. So on the first day of my office job, I just had to wing it. I pretended I was familiar with it. I had no idea what it was. But I quickly rushed home, got a book like Excel in 24 hours or something like that, or 24 lessons. I stayed up overnight. I annoyed my roommates, and I learned enough tricks to impress people in the very first week, enough to get that Excel expert label, which I definitely did not deserve at the time. But yeah, I got it, and I had to live up to it ever since, because ever since that very first week, people kept coming to me with Excel questions, and I had to answer them. I've always been obsessed with automating my own work, and tools and systems that I built for myself have always been like a mini software rather than just spreadsheets. And at some point, I went on to build solutions for others as well, which I still do as a side hustle. So I was happily crunching numbers and pretty much thought Excel was just for that, for numbers and for finance. But that all changed drastically a few years ago when I got one of my most challenging and exciting projects ever. It was to build a school timetable software for an elite ski academy. And when the CEO of the company called me to explain what needed to be done, as he was explaining it, I thought, oh my God, how one would even attempt something like this? I was like terrified. And then he said, if anyone can do it, it's you. And just like that, the challenge was mine, because I immediately thought, oh sugar, now I can't say no. I am being perceived as someone who takes on seemingly impossible tasks. I was honored by that, and I had to prove he was right. I mean, to be honest, he was already familiar with what I'm capable of, because I did some financial modeling for that company when they were a startup, at their startup stage. So, but still, this was a totally different thing, completely something that I was not familiar with. So, so I said yes, and if only I knew what I was getting myself into. So the case was so complex that none of the commercially available timetabling software was able to handle it. So I took the challenge, and many years later, I built a very complex bespoke timetable model. The academy was growing, and with it was the challenge. So the amount of both soft and hard constraints that had to be satisfied was growing exponentially week on week. And Excel part of it, even though crazy complex, was actually the easiest element in all this, because once I know what I want Excel to do, it has no choice but to do it. I will torture it until it does it. So that wasn't a problem. It was basically a combinatorial optimization challenge. So I had to come up with and constantly improve a very bespoke scheduling algorithm. Anyway, long story short, for the first time, I was exposed to and fully experienced the potential of Excel in non-financial environment, and I was fascinated by it. There were no numbers, no sales, no cost, no profit, no quantities, no basically hardly any numbers. There were just names of athletes, teachers, coaches, rooms, lessons, snow conditions, skiing sessions, and so on. And I loved it. And when it ended, I was heartbroken, and I wanted more of the same. But since I wasn't able to find any like a similar project, so instead I went on to play with traditional brain puzzles and attempted to like recreate them in Excel. So, and I must say, they give me a very similar level of intellectual satisfaction, except nobody's paying for it. But anyway, back to Excel. These are some of the substitutes for the timetable projects, and these are just thumbnails of some of my completed projects. Many of you may have seen them already on LinkedIn. There are many more puzzles in progress, but they are so time consuming. I'm not sure when I'm going to be able to finish them. Let's have a look at these in motion now. This is just a short compilation of the puzzles in motion. Obviously, Galton Board is not a puzzle. It's a simulation of a concept in statistics, but it was fun to do. Domino Search, a very popular puzzle in the Mensa books, and one of my favorites. This one, I call it a directional grid puzzle. I actually don't know what its proper name is. Mastermind, one of my favorite childhood games. Nobody wanted to play with me, so now I built it in Excel and I can actually play in it. Abacus, again, not a puzzle, it's a visualization of cool number patterns on an abacus. Next one is word search, classic word search in all directions. Rubik Cube, again, one of my all-time favorites. I absolutely love them, all the way up to 8x8. Cross-figure puzzle with some other challenges. And finally, the maze that went viral and got me all of the unexpected attention in the first place. I mean, it wasn't really viral, but definitely viral in my world. Given the time we have, I won't be able to dive deep into the technical details behind the models, because we would need a week-long summit just for that. But I will give you a quick overview of some of them and a story behind them, and I will focus on key logic or design ideas that made them work. There is no AI involved in any of these in any way, and it's 100% authentic human intelligence. And I also stayed clear of VBA with one exception, because I really wanted, this was my goal, I really wanted to push just the formulas to do all of this, to drive all the logic. So if you're curious about the more details than I will be able to showcase here, then I'm happy to share the files. But to be honest, I would probably, first of all, I don't even remember how I did some of the parts of the models because they're quite crazy complex. But also, I would probably encourage you to have a go at it, at solving a puzzle of your choice yourself, rather than, even if only partially, rather than exploring mine or someone else's model. You will learn much more, I believe, by attempting to solve it yourself. But anyway, let's move on to first puzzle. Okay, I'm going to start with the less cool ones and move on to more complex ones. So an abacus, not a puzzle, but it's a visualization of certain numbers creating nice patterns on an abacus. This kid's toy that I saw in a waiting area somewhere is what inspired me, actually. Obviously, it's not an abacus, but made me think of one. And at the same time, I've only just learned about pasting cells, pictures in cells. And that video tutorial, I think it was Leila's, was still fresh in my mind, and I immediately thought of applying this concept to the abacus. So basically the whole project was about that. The logic was relatively simple, was to represent the beats with ones and the rest of the wire with 0. And then there was a formula that moved the beats to the right to represent numbers. And then based on the number of beats to the right and on the level they were at, the XLOOKUP was looking up pictures and replacing the ones with an image of a beat. Let's jump quickly to Excel to show you the behind the scenes. Okay, Abacus. This one was quite simple to build. So here, basically, once I worked out the basic logic, how to represent the numbers, the way they work on Abacus, for example, let's say we want number 28. So these are the tens, so 20 and 8. So the next thing was to bring it to life visually, make it look like an abacus. So instead of showing just ones and nothing, I wanted to actually show like those beats that we see on the abacus. So I created a lookup table to have those beats, replacing the ones. And so I did. And then the rest was just about getting the visualization even better, Abacus lookalike. So I added some wires instead of the colors. So that looked better already. And now I didn't want the separation here, like I didn't want to have as much space as the whole 10 beads, because that's not how the Abacus works. This is what I wanted to achieve, like a bit of an overlap. And next, I was just playing with random numbers, which weren't that exciting to look at. So instead, I created a table of numbers that looked better visually and arranged them in sequences that formed nice patterns. Even in the table, they already some of them form nice patterns to look at. And then the final step was just the presentation. So I go through that table with the spin button, and the numbers appear here and they represented on the Abacus. So if we go fast enough, that's what creates this smooth visual animation effect. So as I said before, I call this one a directional grid. I don't know its proper name. So the idea here is to start somewhere and we have to work out where to eventually finish in the middle square F, finishing square, having gone through all of the squares once. And so to solve it, I actually created a full path from each of the 24 squares following the directions. So the directions are like 3R means move three to the left, 3 squares to the left, 1D, 1 down, and so on. So I created all of those paths from each of the 24 squares, and each path eventually led to the square F, but only one has done so, having gone through all of the squares, which was the requirement. And then I just added the visualization, and I hard-coded the arrows just for extra effect. So let's jump into Excel. A trigger warning with this puzzle: you may spot an occasional VLOOKUP here and there. And no, it's not cool these days, but bear in mind that I started this puzzle a long time ago, well before dynamic arrays. I was trying to solve it with offset function at the time, but I got stuck and I abandoned it. And then I returned to it in 2024. I still use the concept of offset, but without actually using the offset function because of the dynamic arrays giving me much better options. So basically, this puzzle was just about playing with the addresses of the squares and how those addresses change as you follow the directions. For example, if we start from this one, this square, we move 3 places to the right, then 1 diagonally right, then 3 down to the left, and so on. So to solve this, I created, because one of the conditions was to work out where do we even start. So to solve it, I created a path from all of those 24 squares, a full path, how they change addresses by following the directions. All of those paths led to square F somewhere along the way, but only one had done so having gone through all of the squares once, which was the requirement. So this was the starting point. And once I had the starting point, then I followed the directions from there to support the conditional formatting, and I also hard-coded the arrows for an extra visual effect. So that's how this worked. Mastermind. I absolutely loved this game as a kid, and nobody wanted to play with me, so now I built an interactive version of this, and I can play solo directly in a spreadsheet. This game works the model works exactly as the original game. For those of you who are not familiar with it, there is a randomly generated code which you cannot see, and then you trying to guess it. So you take a first guess, and then the model gives you feedback. So black pins mean that you have the color right, and it's in the right place. However, you don't know which color it is. And white ones are telling you that you've got a color right, but it's not in the right place. And again, you don't know which color and which place the feedback relates to. So based on the feedback, you keep adjusting your guesses, and eventually, hopefully, by the time you run out of all the tries, you crack the code. So I won't be going into Excel for this one because it is actually locked with a password, which I don't remember. And I built that game quite a long time ago, and I don't even remember the details of it. So I will make it available because it is interactive and you can play. But yes, I won't be going behind the scenes for this one. Next is the story behind the Galton Board project. So I came across this page in one of the maths books, and immediately, as soon as I saw that triangle with the dots, even before reading the description of it and knowing what it is, I immediately thought, whatever it is, this is my next project. This is my next Excel challenge. So then I read what it was, and then I liked it even more. So I went on and did some research on Galton Board. So I found this video of the simulation on YouTube, and I was fascinated by it. As soon as I saw it, I'm thinking, oh, this is so going on Excel. I have no idea how to do it, but I was going to do it. So, and this is what I achieved. And you can hardly tell the difference, right? So this was the only project that had to have a little bit of VBA in it, because the concept here is, as each ball falls from the top on the first black pin, it's got an equal chance, 50-50, of falling to the right or to the left. And the same happens on each subsequent level, so that they end up in one of the bins. And with a large enough sample, that final result is that the majority of the balls are in the middle bin, then a bit less on the sides, and so on. So the result always reverts to the natural curve, the bell curve. And so this is a truly random simulation. Every time I run this macro, it's completely different. The balls. So I use the VBA to create a random path for each ball and then memorize it, and then so that I could visualize how its way to the bin. And every time the macro runs, it returns a completely different result, but each time it does revert to this bell curve. So let's now jump into Excel, and I'll show you how it looks in the spreadsheet. So for this one, I wanted it to behave like a true Galton board, meaning I wanted each ball to have a truly random path down to one of the bins. And I also wanted a visual effect to reflect the colors of the bins as they drop into the bins. So to start with, I had to come up with a function involving run between to create a truly random path for each ball. So as I make any change in Excel, it resets the path. But the problem was that I needed to keep this path. Once it was created, I needed it to be fixed throughout the whole duration of the way down to a bin. And to do that, I did have to use a VBA, as much as I didn't want to. So this was basically, at any point, we see 16 balls, and I need to have a random path for each of the balls set and memorized, stored for as long as the ball is in motion down to the bin. So I created those holding places here. So there are 16 balls. A random path is created, is memorized and stored with VBA. So all these paths are memorized just long enough for the ball to makes its way to the bin, and then it resets for the next ball in line. So I tracked how the balls move down to the beans with this schedule. So let's just try to this way. So as one set of balls, like we're getting closer to 16 here, disappears, a new set of balls with new paths starts to appear. So that's, I use this. And then the fun part was the beans. And to be honest, I actually don't remember exactly how I did some of the tricks to make it work. But what I basically did, I kept a record of which ball ends up in each bean. Then I had the beans position indexed, and I was filling them with numbers as balls were dropping into them. And then I was just looking up the right pictures to fill them with for visual effect. I think I used some, I had a table to look up the balls, colors, and the arrows as well for this part of visualization. So this simulation involves I think a total of 1,000 balls, and each time it is truly random, and it creates that bell-shaped result. So it is a true simulation of Galton Board. Cross-figure puzzle. Okay, so this one was quite an interesting challenge, because for the longest time I had no idea how to solve it or where to even begin. So I started with the same logic that I would use if I was solving it with a pen and paper. So I mapped out all the information that was available, was obvious to start with. So I created loads of empty arrays, and I filled them in with information such as which squares will be filled with a number and which will be blank. I also marked the starting positions of all horizontal numbers and all vertical numbers, as well as their lengths. And I also indexed the digits within each number, and also indexed the order of each number. So like here you can see number 911, the first horizontal number. I gave them unique identity. So this one was first horizontal number, then the 5505 is second, third, and so on. And I did the same for the vertical ones. And once I had all this laid out, I secretly kind of hoped that this would be enough and it will somehow reveal the solution. But of course it didn't. So here the turning point was to identify the crossings, which horizontal numbers cross with which vertical ones, and at which digits. So this was easier said than done. The model and the logic behind it got quite intense, and the model went completely mad. It's let's just say it's not the most straightforward one, and let's jump into Excel and I'll show you how crazy this got. But I was determined to solve it, and I did, so that's what matters. Right, so this one was really tricky. If anyone asked me to do this from scratch again, I would probably struggle. Let me just zoom out on this one. So this tab was a placeholder to gradually reveal the solution step by step, as well as I had all these supporting matrices set up, which were filled with basic information like where do the numbers start, how long they are, and so on. And I have that information for both horizontal and vertical numbers. So a pretty straightforward setup, but unfortunately the simplicity ends here. Now to the solution. This is how it looks from the bird's view. So it's got those giant blocks of logic repeated over and over until the solution was reached. There's quite a lot of logic going on in each of the blocks. And I really struggled to come up with the right method to solve it. And eventually, I'm pretty sure I've overcomplicated it, but anyway, it worked. So I was using this crazy visual to help me write the formulas, because what I wanted to do, or what I decided to do, was to treat each vertical number as horizontal one. So I would be comparing, I would have a set of original horizontal numbers, and I would be looking for crosses of them crossing with vertical numbers, which were actually presented as horizontal. That was that got quite messy. So I have no idea how I managed to do it, but it somehow worked. So the domino search was another one that I struggled to solve for quite a bit. Once I've built a solution for set 1, as you can see, I have total of 12 sets here. So once I built a solution for set 1, it failed on set 2. So I added a bit more logic and it worked, and then it failed on set 3, and so on. So it kept failing all the way until set 12, at which point I ran out of sets, and I wanted to test it even more, so I created a kind of random, I manually put a random set, and it failed on it. So, but at this point I decided not to push the model any further, because all those sets I got from Mensa books, and I thought maybe they are arranged in a specific solvable way, and my random set may not necessarily have a solution. So I don't know that, but I just didn't want, I decided basically to stop there. And I think for this one, it's better to jump straight into Excel, and I'll show you how I did it and what I did. Okay, this model is even crazier than the cross figure one. Let me just zoom out and show you how this looks from distance. So I've got, again, I'm repeating blocks of logic. This area is just one block of logic, and I have 15 of them. And there is a lot going on within each one. There is like up to, I think, 11 steps within each block, and they each work out the different things. They will first start with the low hanging fruit, the easy tiles that can be identified because there is no other option. And from there, it gets more complex. So we will be looking for tiles to avoid gaps or isolation. Some parts of the logic would look to eliminate conflicting or duplicate possibilities, and so on. So each of the 11 steps within each of the 15 iterations looks for different things, very complex, and eventually, one by one, the solution is revealed, and the identified tiles are also marked off here. And for the presentation, I had the total of 12 sets. I combined them all together, and I also had a version where they looked like actual domino. Traditional word search puzzle now. So the easiest part in this puzzle is to solve the numbers that go vertical, the same way that as we naturally read them, meaning horizontal left to right, because for that you only need to combine all the characters into strings, then search for each of the words within each string, and then track the starting positions and the length of them for visual highlighting, and finally just remove the found words from the words to find list. So instead of building different logic for all the other options like vertical and diagonal and even horizontal left to right, I just manipulated the original matrix in a way so that it behaved as if it was horizontal left to right. So once I had so instead of 8 complex different cases, I had 8 simple horizontal left to right cases, and I could just repeat the same logic for all of them. So let's go to Excel now and see how it looks in the spreadsheet. Right, word search. This one, actually, the solution happened just in one tab, let me just zoom out and show you how this looks from like a bird's view. So these are all the sections, the 8 sections to solve the 8 different layouts, being the 2 horizontal ones, 2 vertical ones, and 4 diagonal ones. So as I mentioned before, the simplest case is the to solve is the horizontal left to right, so this is this matrix, where you have to, all you need to do is to combine all the letters into a string, search for words within that string, and then just gather some information like where does the word start, position-wise, and how long it is, and so on, to support the visual highlighting then. So that's it. So that's relatively simple. And for all the other cases, I used exactly the same approach, the same logic, but I manipulated the matrix, this matrix, to behave, for all the cases, to behave exactly as horizontal left to right. So for horizontal right to left, I simply reversed the order of the columns. So, for example, the word wipe is here, but in the original matrix it's actually here, W-I-P-E. And as I also tracked the original position of each letter, I could then highlight the word in its as it appeared on the original matrix. So for vertical ones, I simply transposed the matrix, so I just flipped it on the side. This was also transposed, and in addition, reverse order of columns. The diagonal ones were more tricky, and for this I had to use a technique that was combining drop and V-stack to shift the columns progressively. So instead of the letters looking like the words being having each letter in a different row, I wanted to see them all in one row. So for this, I kind of had this visual help. Like I effectively wanted to cut off this triangle and glue it underneath to make the letters drop into how I wanted them to be. So and this is what allows me to find the solution using the simple logic for this case, but actually highlight them then on the original matrix as they appear. Rubik cube. So this one is this model was not to solve the cube automatically. It was just to visualize and animate how it changes with each move, and also view it from all possible angles. So for this, I started with giving each tile a number, so I could track how it moves when a twist to the cube is applied. And for this, I even sacrificed, as you can see, my own physical cube, and as well as used some like a paper cutout to help me visualize what happens with each move. So in total, I defined 36 possible moves, and for each one, I worked out exactly how the numbers shift, what happens to each number on each of those moves, and I created a database of those. So when you select a move from a drop-down, each cube shows you what happens to each of the sides after this moved. So I will show you this bit in Excel, but just want to say that this model doesn't actually solve the cube for you. You still need to know how to solve it. And for my demo, I started by scrambling the cube with some random moves, so it was totally messed up randomly. And then I looked at the mixed up cube, and one by one I selected moves from the drop-down to solve it based on the standard solving algorithms that I know. So this was quite tedious actually, because in real life, I don't think in terms of rotate the top clockwise or the turn right face anti-clockwise or anything like that. It's just all muscle memory, so it's quick. And here, I had to spend a lot of time really thinking carefully, not only what move to perform, but also how it's called, and then select it from the drop down. So, but I did that, and then I recorded it in a with an extra speed, so that it could, because otherwise it would have been quite boring. So with the speed is similar probably to one of the record breakers in cube solving, in Rubik's cube solving. So this project wasn't about automation, it was just about being creative with presentation and showing how Excel can bring to life even something like Rubik cube, both logically and visually. So let's now jump to Excel. Okay, Rubik cube, that was a lot of fun to do. What I wanted to do was not to solve the cube, not for the model to solve the cube, but just to make it possible to rotate the cube in it as if you were rotating the physical one, and to see how the sides look from all possible angles at the same time. So to do that, I gave all the tiles a unique numbers, so you can actually see here. These are the numbers that I gave them to start with, and then as you move the cube, I've identified 36 possible moves to the cube, and each move shifts the position of the tiles in a specific way. So I created a database of what happens to each tile, each of the 54 tiles and 36 moves there. So each tile changes the position accordingly to the move. So this is just a database of what happens to the tiles. So we start with an unscrambled cube, and then as we apply moves of our choice, which are these moves selected here in the drop down, as we apply them, the position of the original tile changes through the moves. And at the end of it, and I've given it up to 500 moves, so that's plenty to solve the cube and play around. And at the end, we always have the most current view, which is reflected here. So this was the starting view. This is the final view, which actually current view rather than final, always current view. And then these are taken as pictures and put together to look like a cube. And so for the presentation, for the visual, what I did, I scrambled the cube with these random moves. These were just completely randomly selected. And then I looked at the cube and I picked all of these moves one by one to actually solve it. So let's try to mess it up and let's just get rid of everything. So this was the starting point is an unscrambled cube, and we can mess it up in any way we want. So we can just select moves, and obviously this is not messed up enough. It's easy to solve, but you would select quite a few moves to mess it up properly. And then by looking at the cube, you need to start actually selecting moves that make sense and that lead to solving it. So let's just undo this. So for the presentation, what I did, I recorded going through all these steps one by one, and I then controlled it with the spin button. So as I go, just a step-by-step only is revealed, and that's how the cube changes progressively. So finally, the maze that went viral in my world and got me all of this unexpected attention and fame in the first place. So there was no particular inspiration for this one. Just for some reason, I kept thinking how something like this could be done in Excel, and I did want to, I just saw it in my head in Excel and in motion, and I just had to do it. So just like with the other puzzles, I had no idea where to start, how to approach it. So I was thinking, okay, best to start as if I was solving it with a pen and paper. What would I do? So I mapped out all the ingredients that I knew as a starting point, and then some relationships between them. Worked out the relationships between them. And in this case, the solution actually just revealed itself. So like in real world, if you were solving it, you would choose a random path, you would eventually hit a dead end, and you would revert back and try a different path, and so on. So if on a larger sample, you may want to block the dead ends and the paths with dead ends that you've already visited, so that you don't repeat that. And that's what I actually did in Excel. So let me show you how it looks on the spreadsheet, in the spreadsheet. Okay, so this one was relatively simple. I just needed to be a bit creative because I couldn't write that crazy recursive lambda. But a quick diversion. Let me show you how fun it is to actually create a maze in Excel. This is not my idea. I found it on YouTube. So basically you start with nested rectangles. Then you add some random holes in it. Then you decide what you want the path to be. Then you block all the other possibility to go elsewhere other than this path. Then you remove the path and you've got the puzzle now. This is your starting point for writing formulas to solve it. So I started with working out for each of the cells within the maze, whether they had top, bottom, right and left border. And this helped me to identify cells that had 3 borders, which means, like this one, which means they are dead ends. The only way from here, there is no way forward, there's only way, like you can only go back on yourself. So these are dead ends. And once I identified those initial dead ends, I marked them with crosses, I also then identified the remaining cells which had possibilities to move forward with E. So these were empty cells and possibilities of being a solution, part of the solution. So once I had the initial dead ends marked, naturally the cell next to it, just before it, would become the next dead end, and then this one, and then this one, and then this one, and so on. And eventually what was left was just the clear path, which was the solution. So I repeated the same logic to identify the X's, the dead ends, and the remaining empty cells step by step. So it took about 20 steps to at which point there was no more new dead ends, meaning that it was just the solution that was left. So I had my solution, I had my path. This was all the E's, but I wanted to create this visual of walking through the maze step by step. So I then had to create another 140 or so steps, to basically reveal the E's just one by one. So once I had the whole path marked like this, then I could use it to back up the conditional formatting and reveal the path step by step, just like I wanted. And I had 4 different samples, and for the final presentation, I made them run simultaneously. So the maze went viral, but very quickly my thunder was stolen by this guy Bo. He created this crazy one-cell lambda formula. Now, recursive lambda, for me, this is Excel's way of saying, trust me, I've got this. And I'm like, are you sure? So it's impressive, but honestly, how many of us are comfortable writing a formula like this? I find it fascinating, but also quite difficult to fully digest. I did spend a lot of time trying to dissect bit by bit this particular one by watching his video on YouTube. But I gave up when he introduced the f function there. So despite my failure to fully understand it yet, I think the case of this very simple puzzle is perfect to study the potential of lambda functions like this. So this is impressive, but however, such a complexity is not a must to solve this puzzle, a puzzle like maze. So he did it in a very complex and fancy way, one cell formula. But I also achieved the same result with just basic logic, mainly if, and, or, so really basic logic, and a bit of a clever manual recursion. So, and that's pretty much it. So it was still possible to solve this puzzle and create the presentation without knowing how to write a recursive lambda function. So let's have a look at both approaches. The puzzles that I did were of all sorts of nature, and some of them required the same certain steps to be repeated over and over again until the problem was solved. So in theory, that screams recursive lambda, right? And that's what I immediately thought of as well. But what if you can't write such a complex formula? Some of you are probably thinking, that's a piece of cake. Kudos to those who can. I did try to write it for the maze, but I couldn't. But I was still determined to solve the puzzle anyway. So how did I do it? I just repeated the same block of logic and calculations multiple times, either by guessing and overshooting the number of iterations that you would need, or just by setting up a generous maximum. Each block was applying logic and calculations to the solution of the previous ones, so it was a manual recursion effectively. And I actually like to see the iterations unfolding one by one, rather than having the solution just pop out and everything be hidden in one formula. So is this approach scalable? No. But I wasn't building a tool for the masses. I was solving a very specific puzzle of a very specific size. So just like with the timetable project, it didn't have to work for every school. It only had to work for this particular academy, for their unique constraints and their unique size. And in fact, in this case, it was the other way around. The one size fits all commercial software actually completely failed in this case. So sometimes we do need to build bespoke solutions that don't need to work on any data set. They need to work well on a very, very specific one. So the point is that just because you can't write a recursive lambda, it doesn't mean you are out of options. You can probably still solve the problem. And both methods have their strengths and the trade-offs. And obviously the right choice depends on the scale and nature of the problem, and as well as your own skill set. Now, this is not a great visual, so don't even attempt to try to read it. It's just to show that I did extract and analyze all formulas and other Excel features that I used for each of the projects. And it's showing that if is the clear winner here when it comes to functions, and it's supported by conditional formatting for visual flair. So there was about 40 total functions that I used, and as you can see, only about a quarter of them are the hot ones used in majority of the puzzles. So that just proves the point that you don't really need to know that many functions to solve complex problems. So I find it quite refreshing to know that in the era of sophisticated tools like AI, Python, Lambdas, etc., basic logic still holds the crown. So why do I do this? I do feel that my Excel skills have catapulted to another level after the timetable projects. Life has never been the same since. So I think solving something like puzzles in Excel is a fantastic platform to get better at Excel. What makes you advanced in Excel is not the latest functions that you know or the levels of courses you did and the certifications you obtained. It's actually your ability to use Excel to solve problems. And to get better at solving problems, well, you've got to practice solving problems. And I believe you can only get so much better by studying generic tutorials with random dry case studies, but you can get exponentially better by solving real life problems, and not just any problems. The best ones are those where you are either emotionally or financially invested in some way. So you either solving a personal problem or a challenge that excites you, or you're getting paid for solving someone else's problem. And if you lack such challenges in your daily work, create them, self-inflict them upon yourself. Look no further, just solve puzzles. I highly recommend that. So I don't do puzzles for a living. I just like to break Excel when no one is looking. And I dare you try it too. Sometimes the fastest way to grow is to build something just for the fun of it. Thank you. I hope you enjoyed the presentation and you already start to see the real potential Excel has to change the way you work. If so, keep watching this space, because the serious automation magic only starts here. There's much more to come, and my future content will actually be work related. And if you want to learn how to automate your management accounts so that they update with just a few clicks and take you from this state to this state, then I've got a full masterclass linked below. Check it out when you're ready. Thank you for your time, and bye for now.